All right, so looking at 15.1, moving into triangles and some specific definitions and theorems within triangles, but still dealing with angles. We'll continue some of our stuff from module 14 with angles and using those with parallel lines as well. So our essential question here is, what can you say about the interior, exterior angles of a triangle and other polygons? So as we already saw during our group activity in class, during this exploration of interior angles and triangles, we saw that the sum of the angle measures of a triangle is 180 degrees. So we saw that through our investigation, but let's go ahead and prove that now. So look here, we have a proof here partially filled in with our diagram. So we draw a line L through point B parallel to AC. Okay, so we're parallel here. And that parallel line will give us some important information, which goes in this next step. So we know measure of angle 1 is equal to measure of angle 4. So we're saying 1 and 4. Then we also know that 3 is equal to measure of angle 5. And our reason for that is alternate interior angles. Then we know that the measure of angle 4 plus measure of angle 2 plus the measure of angle 5, so we're doing this whole set here, is equal to 180, because angle addition postulate and definition of a straight angle. So those three angles all added together give us that straight line. So from that, we then can write the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And our reason for that would be substitution. Property of equality. And all I did is, since we had stated that 1 is equal to 4, so we can replace 4 with 1, and 3 is equal to 5, so we can replace 5 with 3. And then reflect, what does the triangle sum theorem indicate about the angles of a triangle that has 3 angles of equal measure? So go ahead and write down your answer for that. We'll share that out when I call on a couple of you to share out your thoughts on that question. All right, so next we did this activity exploring interior angles of polygons, and we worked through this in class, coming up with our rule for an n-gon, where it has n number of sides, n minus 2 the number of triangles, and so we came up with n minus 2 times 180 equals the sum of the interior angle measure. Some of us say 180 n minus 2 doesn't matter. Multiplication order does not matter. So then the sum of the measures of interior angles of a convex polygon with inside is, as we said, and I'll write it the other way. So I get 180 times n minus 2. So let's work through a problem here. So using interior angles for a non-agon. So a polygon with 9 sides, we want to find the unknown angle measure of x. So we know the total of a non-agon is going to be 180, 9 minus 2. So that gives us 180 times 7. Multiplying that out gives us 1,260 degrees. So we know that is the total of the sum of all those interior. And then what we're going to do is subtract all of those. So what I'm going to do is add those up first. So then we get 135 plus 98 plus 102 and so on. And so once those are all added up, we come up with 1,002 degrees that are in there, and then that x. So when we subtract 1102, we then get our missing value of 158 degrees. All right, so up here at the top, we got a couple 3 and 4. Those are your turn, so go ahead and do those on your own. We'll discuss those when we come back into class. And we have one more theorem here, so we're going to prove the exterior angle theorem. The exterior angle theorem states the measure of an exterior angle of a triangle is equal to the sum of the measure of its remote angles. So what it'd be stating is that angle 4 is equal to angle 1 plus angle 2 there. So with the proof, we know angle 4 is an exterior angle. It forms a linear pair with the interior angle 3, because we have a line there. And its remote interior angles are 1 and 2. So with that, angle 3 and angle 4 are a linear pair, and that is given. And then 1 plus 2 plus 3 equals 180, and we know that from something that we already proved today, which is the triangle sum theorem. We then know that angle 3 and angle 4 are supplementary. And that's linear pair theorem. Which then gives us that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. And that's the definition of supplementary angles. And then with that,